Good morning, hello and welcome back to CS492F, Futures of the World. And this week we're going to discuss future of transportation and travel. This topic D has been prepared for by Dongkyu Yoon, by Junho Park, and by Min Sung Hwang. So I'd like to ask these three to turn on their camera. Would you like to start by introducing yourself and how you plan to organize the presentation?
Hello, my name is Dongkyu Yoon, and our teammate is Junho Park and Min Sung Hwang. Today, my part is about electronic vehicle and autonomous car, and Junho Park will talk about such as Hyperloop and other part of future transportation. So today, I'm going to talk about the future of transportation with a particular focus on electric cars. So we'll explore the various advantages, current trends, and potential challenges associated with the ongoing electric vehicle revolution. So electric cars, as the name suggests, run on electricity, and this means they produce zero tailpipe emissions. This reduction in harmful emissions not only helps combat air pollution, but also decreases our reliance on fossil fuels, contributing to a cleaner, more sustainable future. So let's take a look at the future of transport, whether it is appropriate for the future transportation.
Transport is the third largest source of greenhouse gas emissions worldwide, which means that rapid action is urgently required. Moving from oil-powered vehicles to electric mobility is part of the solution, but is not the silver bullet. Electric passenger vehicles will become increasingly popular in countries like the UK. On the global scale, however, we will see continued growth of fossil fuel powered vehicles. Because of this, and the fact that it takes about 15 years to turn over a fleet, we will see high emissions from transport for a long time into the future. And while buses and passenger vehicles will become increasingly electric, there are other segments of the market where it's much more difficult to electrify. Vans are currently the fastest growing form of road transport in the global north, and this is one area where it's very difficult to get a wide range of affordable electric vehicles. Trucks and aviation are still at the stage of experimentation and concept vehicles. Contrary to what is often believed, electric mobility is no zero-emission solution. Emissions may be generated in the production of batteries and vehicles, and the processing and recycling of discarded vehicles and batteries may also incur emissions. Electrification of transport alone will not make transport compliant with the commitments in the Paris Agreement. Other technological changes will also be required. The fuel efficiency of vehicles must be improved. And for the long term, we need to develop hydrogen-powered vehicles. The trend towards larger and heavier vehicles, such as sports utility vehicles, needs to be reversed. We need to move towards smaller and lighter vehicles. We will need to use public transport more, cycle more, walk more, use e-scooters, and fly much less. This means that we need to redesign our cities to make these forms of behavior more attractive. We also need to connect cities by affordable and convenient high-speed rail connections. At COP26 in Glasgow, I would like policymakers and politicians to address transport holistically. That means more walking, more cycling, more public transport, more e-scooters. As part of that, we need to make vehicles that are shared and electric subordinate to other healthier forms of transport.
So the video showed the importance of electric vehicle as a future transportation. Now, I will talk about advantages of electric cars. Electric vehicles come with a range of benefits, both for the individual and the environment. First and foremost, they offer significantly lower operating costs compared to traditional gasoline-powered vehicles. Electricity is cheaper than gasoline, and EVs require less maintenance. Additionally, electric motors provide instant torque, giving electric cars quick acceleration and a smooth, quiet ride. Perhaps most importantly, electric cars have a smaller environmental footprint. They reduce greenhouse gas emissions and improve air quality in our cities. So this is a video about electric vehicle and also about autonomous cars.
The future of transportation, exploring electric vehicles and autonomous cars. Hey there, ladies and gentlemen, and a warm welcome to our incredible channel. Here, we take you on an awe-inspiring adventure through the captivating worlds of technology and innovation. Today, hold on tight as we embark on a thrilling journey into the future of transportation. Brace yourselves for a mind-blowing expedition where electric vehicles and autonomous cars steal the spotlight. Get ready for an electrifying ride you won't soon forget. Buckle up, my friends, because it's time to ignite our engines and dive headfirst into the exciting world that lies ahead. Let's rev it up and hit the road. The rise of electric vehicles. Hold on tight, folks, as we venture into the realm of electric vehicles, also known as EVs. These revolutionary rides are powered by electricity, making them the superheroes of the automotive world. Not only are they sleek and stylish, but they also boast incredible performance and, most importantly, they're kind to our planet. The demand for EVs has skyrocketed as manufacturers continue to unveil jaw-dropping models that seamlessly blend power, beauty, and sustainability. Get ready to be mesmerized by the mesmerizing world of electric vehicles. Get ready to rev your engines as we explore the incredible lineup of electric vehicles available on the market today. From the luxurious and lightning-fast Tesla Model S to the practical and pocket-friendly Nissan Leaf, there's an EV for every driver out there. These state-of-the-art machines come packed with mind-boggling features that redefine the driving experience. We're talking about longer ranges, lightning-quick charging times, and cutting-edge innovations that will leave you in awe. As the charging infrastructure expands and battery technology leaps forward, the era of electric mobility is on the verge of transforming the way we commute. Buckle up, because the future is electric. The autonomous revolution. Fasten your seatbelts as we venture into the exciting realm of autonomous cars. These futuristic vehicles are equipped with advanced sensors, artificial intelligence, and state-of-the-art algorithms that enable them to navigate the roads without human intervention. The rise of self-driving technology has sparked a revolution in the automotive industry, propelling us into a future where safety, efficiency, and convenience take center stage. Imagine a world where traffic accidents are drastically reduced. Traffic congestion becomes a thing of the past, and commuting becomes a productive and enjoyable experience. It's not just science fiction anymore. It's becoming a reality right before our eyes. The possibilities are endless, and the impact on our transportation systems and society as a whole is bound to be transformative. So sit back, relax, and let your imagination run wild as we explore the fascinating world of autonomous cars. The future is here, and it's driving itself. Companies such as Tesla, Waymo, and Uber are leading the charge in developing autonomous driving capabilities. These vehicles can navigate through traffic, detect obstacles, and make split-second decisions, all without human intervention. While fully autonomous cars are still undergoing rigorous testing and regulatory approval, the progress made so far has been awe-inspiring, opening up a world of possibilities for the future of transportation. All right, listen up, folks. I'm here to talk about something that's going to blow your minds. Electric vehicles and autonomous cars are changing the game, and it's not just about the automotive industry. We're talking sustainability, baby. The shift towards EVs is a game changer, no doubt about it. We're talking about slashing those greenhouse gas emissions, improving the air we breathe, and saying goodbye to our addiction to fossil fuels. And guess what? Countries and cities all over the world are getting in on the action, adopting eco-friendly policies and giving incentives for people to hop on the electric vehicle bandwagon. But that's not all. The integration of autonomous cars is a whole new level of awesomeness. Picture this: shared autonomous vehicles zipping through our cities, cutting down on traffic jams, freeing up parking spaces, and making transportation accessible for everyone. This is the future, my friends, and it's going to make our lives better, safer, and more efficient. So, as we wrap up this incredible journey into the future of transportation, I want you to feel the excitement in the air. We're on the brink of a revolution, and we're lucky to be witnessing it firsthand. The convergence of electric vehicles and autonomous cars is going to change the world, my friends. I hope this little exploration has sparked your curiosity and painted a vivid picture of the mind-blowing possibilities that lie ahead. The future of
I will introduce the current electric car trends. The electric car market is experiencing rapid growth, with sales soaring in regions across the globe. So you can see the graph about the electric vehicle market size in the right. This growth is in part due to significant advancements in battery technology, leading to increased range and faster charging times for EVs. The market is becoming increasingly competitive as established automakers and startups alike invest heavily in EV development. So this is the current status of autonomous vehicles. So we can classify into level 0 to level 5 about autonomy level. And the current status is only to level 2. So level 0 is no automation. So the driver has to drive the car by himself or herself. But at level 1, the car has assisted driving technology, so such as lane guidance or adaptive cruise control. And at level 2, it is partially automated driving. So it is really similar to level 1, but it has more advanced guiding assistance. And to level 3, 4, 5, it is currently on developing, and this is not widely used in the world. So from level 3, it is highly automated driving. So at level 3, the car has traffic jam assistant. And at level 4, it is called fully automated driving. So at level 4, we can have local driverless taxis, such as robotaxi, and pedal steering may not be installed in the car. And finally, at level 5, it is called autonomous driving. And as level 4, without spatial limitations and autonomously in all conditions. So in level 5, the driver can just sleep in the car and do not need to drive the car. So let's see our self-driving cars, the future of transportation.
As night falls on the streets of San Francisco, these fully electric cars are gearing up for a takeover. And yes, they are fully electric. No humans behind the wheel.
There we go. This is weird. No one to say hello to.
General Motors owned Cruise allowed our cameras to be the first to go for a spin in a car they call Poppy.
Buckling up, and we're off.
But even before we got going, Poppy ran into a problem.
We got traffic coming. We got a double parked semi. This is just the beginning of our trip.
Without enough room to easily pull forward, the car tried backing up, then
We noticed something happened on your trip.
Poppy's computer crashed. Cruise says the failure was caused by a bug that very infrequently causes the autonomous vehicle to shut down when it attempts to go in reverse.
I'm sorry for the trouble.
After some human intervention, a system reboot in about 30 minutes,
All right, second time's a charm.
the car was good to go.
The hills of the Bay Area. Look at this.
Situations like this are actually part of what drove Cruise to start their operation on the complex roads of San Francisco.
You have to put it in the most challenging environment.
In June, these driverless cars became the first to navigate a major city with paying customers on board, and it's the unpredictable human behavior that's the true training ground for these Chevy Bolts and their slew of sensors, and they've already seen everything from random roller skating parties to wildlife. Despite the initial speed bump, my ride was smooth to the point that you'd forget no one was driving.
All right, so here's the thing. This car still has its steering wheel there, still has its pedals. But if this is the future, how long till those are gone?
Cruise co-founder Kyle Vogt says these Bolts are just the beginning.
This does not look like a car. Are you calling it a car?
It's what comes after the car.
This is what Cruise calls the origin.
This is legroom right here.
Here it is.
Wow, look at this.
A 6-passenger vehicle, minus the driver and minus the steering wheel.
How much space is actually in here?
It's the same size as a regular vehicle. We've just gotten rid of all the stuff that you don't need.
Origin is in its testing phase and expected to roll off the assembly line next year. Meanwhile, the ride for Cruise has been a little bumpy. This summer, federal safety regulators launched a special crash investigation into an accident that left passengers with allegedly minor injuries. In April, one of their self-driving cars went viral when it was pulled over because a human forgot to turn on its headlights. And in June, a bug caused some cars to temporarily slow down and stop, forcing other cars to go around them. Cruise says all those problems have been fixed.
A lot of your hiccups have come before everybody else's. Is it hard getting people to trust autonomous cars, especially being first?
Well, important thing to realize, we're only a few months into this, and so we're learning a lot as we go.
Still, some safety advocates say Cruise and other self-driving car companies should consider pumping the brakes.
What do you say to people who see this and think that we're moving way too fast towards autonomous driving?
Well, to start with, I mean, the status quo is not a pretty picture. You know, we feel like we're in a war against car accidents here. So we feel a sense of urgency to get this technology out there as soon as it can be done safely.
And guys, the driverless car wars are heating up in Silicon Valley. Google's self-driving car venture Waymo, which we've covered before, which we also saw out on the streets, is also nearing its launch in San Francisco, while Cruise plans on announcing expansion to other big cities later this year. Guys?
So, Gary, I mean, as we saw there, you were involved in what the company called a failure of one of their self-driving cars. Did you ever feel unsafe at any point?
I wouldn't say I felt unsafe, but it did seem like it was a situation that a human driver would have figured out pretty quick. Apart from that, the car seemed to drive very much on the defensive side. And in the area that they operate right now, they have to keep the speed under 30 miles an hour, usually at night when traffic is extremely light. As for that glitch you saw, Cruise says it's now fixed. Guys?
Okay. All right. Gotti Schwartz, thanks for being so brave, Gotti.
I know.
Wow.
Hey, thanks for watching our YouTube channel.
As night falls on the streets of San Francisco, these
We don't know exactly when we're going to be able to buy autonomous cars, but we do know the opportunity is coming soon. The idea first appeared in the 1930s in a monthly sci-fi magazine called Air Wonder Stories, but it wasn't until the 1980s when Carnegie Mellon University's NavLab created the first self-sufficient and truly autonomous car. Bryce and I actually got to ride in one of NavLab's later public bus models in 1997, and trust me, having your bus driver stand up and walk to the back of the bus while you're tearing down the highway at 55 miles per hour is a surreal experience. Since those years, autonomous vehicles have come a long way, especially in the last 10 years. In 2008, the autonomous movement's biggest achievement came when a self-driving Volkswagen Passat was able to recognize a stop sign and apply the brakes on its own. 2 years later, in 2010, Google had built an entire fleet of autonomous cars and clocked a total of 140,000 miles on Californian roads, driving alongside other cars and pedestrians and obeying not just stop signs, but all traffic signals, including traffic lights. By 2012, that same fleet had covered 300,000 miles without a single accident. Google and VW aren't the only ones with their sights set on the self-driving market. Mercedes-Benz began testing autonomous driving in the 80s when NavLab was around, and recently revealed their luxury F015 concept model, equipped with internet-connected displays that can be controlled via eye tracking and hand gestures. Last year, a BMW drove itself down the Autobahn, Audi sent an autonomous vehicle up Pikes Peak, and at the Tokyo Auto Show in November, Toyota unveiled its Prius Avos, which is an acronym for Automatic Vehicle Operations System, which can be summoned by the rider remotely. Now, despite some legal, safety, and privacy obstacles standing in the way of companies bringing self-driving cars to market today, unknown questions like, can the system perform in a blizzard, or who is going to be legally responsible if the autonomous vehicle hits a pedestrian it didn't recognize? Automotive CEOs still think the autonomous car is inevitable as the technology advances. Google has said it wants its cars in the hands of consumers by 2017, and Tesla's Elon Musk wants passengers to, quote, get in, go to sleep, and wake up at your destination by 2019. By 2020, GM, Mercedes-Benz, Audi, Nissan, BMW, and Renault all expect to have at least semi-autonomous vehicles available for purchase. Jaguar is expected to release one in 2024, and Ford plans to enter the market by 2025. If these predictions go as planned, the world is going to be in a much different place by the time 2030 is here. 1.2 million people die in auto-related accidents every year in the world. In the US, 40% of the deaths involved alcohol. Now, computers don't get drunk or mess with their cell phones or get distracted, so expect auto-related deaths to approach zero as more autonomous cars hit the road. Not only is it going to be safe, but it's going to be fast. The average American spends 52 minutes commuting to work today, but not for long. Say bye-bye to stoplights and traffic signals and say hello to high speeds. The autonomous car of the future will be able to plot a direct course and communicate with the other cars on the road so that as many as possible can fit and keep the flow moving as quickly as possible. Autonomous cars are going to be accessible to the disabled, elderly, and young, which raises an interesting question. If the autonomous car is no longer a car but a computer, then do we need to regulate it as much as we do with the cars today? Will you need a license to ride in one? I doubt it. Our environment is definitely going to thank us. More efficient driving means less energy is burned into our atmosphere, which means less carbon dioxide, which means cleaner lungs, healthier humans, and a longer lifespan for our planet. In disaster relief situations, hurricanes, fires, tsunamis, an army of autonomous vehicles could be ready for rescue missions. Finally, people are going to be happier. Stressful hour-long commutes shackle human joy. It is going to be nice to get rid of them. Thanks for watching. You can click on the screen to watch our rundown. We don't know exactly when we're going to be able to buy.
So as the industry of EV and autonomous car develops, the charging infrastructure becomes very important. A key factor in the widespread adoption of electric cars is the expansion of charging infrastructure. This includes the ability to charge at home, at work, and at various public locations, making electric vehicle ownership more convenient and accessible. So we can classify the level industry about charging infrastructure. So at level 1, it takes the time to charge for about 30 to 40 hours. So it is really long to charge the car. And the cost to charge is very low, and the location is home and office. But when we develop it to level 2, the time to charge becomes smaller, but the cost to charge become more expensive, and the location has added to public, and at level 3, the time to charge has decreased very large, but the cost to charge is very expensive. And the location is to all travel locations, so we can charge wherever we want. So now let's take a look about connected cars in the IoT.
The easiest way to think of Internet of Things is essentially imagine all the things that you use in your everyday life that you can see and experience, and some things that you don't. What would happen if those things were always connected to the internet? You're driving around a city, you want to know where the empty parking spot is. Your car is connected to the internet, the parking meter tells you where the empty spot is, and you go and park. Here, the concept is of a connected car, where all the things that go in the car that are connected all the time. As IoT becomes more and more prevalent, and as we connect more and more things to the internet, the efficiency gains will be huge. If we didn't have LTE, then we'd have to rely on things like Bluetooth and Wi-Fi, which works sometimes quite well, and sometimes there's a lot of interference. Now, when we put LTE modems into IoT devices, now we have the ability to connect these devices seamlessly in every part of the world. When we're able to use LTE in IoT devices, it just makes the vision of IoT happen much faster and much more seamlessly. One of the big areas of impact from LTE would be in the infrastructure of the cities, because many times we want to deploy these connected devices in remote areas and also all over. So for example, we want to have all the light bulbs that are on a freeway connected over LTE modem. So if you detect some anomaly like a car crash, you're able to detect it right away and communicate back. Now, as we move from 4G to 5G, everything we're doing in the 4G space in enabling LTE devices gets much better. The easiest way to...
So, as we have seen before, the electric car has very benefits about eco-friendly perspective. So government has initiatives. So governments around the world are taking significant steps to encourage electrical vehicle adoption. These initiatives include policies that promote the manufacturing of electric vehicles, tax credits, and subsidies for consumers who choose electric over traditional car. And to assess the environmental impact of electric vehicles, a full life cycle analysis is essential. Studies have shown that electric cars generally have a smaller carbon footprint compared to internal combustion engine vehicles. However, it's important to note that the overall environmental benefit depends on the source of the electricity used for charging. In conclusion, electric cars represent a significant part of the future of transportation. They offer environmental benefits, advanced technology, and economic advantages, making them a critical step toward more sustainable, cleaner cities and a healthier planet. Now, I will talk about connected cars. The concept of connected cars and their potential and the profound impact they are having on the automotive industry and society as a whole. Connected cars, often referred to as smart cars, are vehicles equipped with internet connectivity, an array of sensors, and sophisticated software. These vehicles have the ability to communicate with the internet, other vehicles, traffic infrastructure, and even pedestrians revolutionizing transportation by enhancing efficiency and safety.
Cars that can talk to each other, interact with traffic lights, and even see around corners. The advent of 5G could make these real, bringing the faster speeds and greater bandwidth needed for smart traffic systems and truly autonomous vehicles. But it's not the only option for connecting cars. It's up against a more established Wi-Fi based technology. There's a debate about which is better. The choice is between the existing Wi-Fi standard called DSRC, or Dedicated Short Range Communications, or CV2X, Cellular Vehicle to Everything, that would eventually use 5G networks. China was first to make a decision favoring cellular technology for its cars. With recent developments in 5G, that could be handing China an early lead.
Their focus is leading to this real time to market advantage, and frankly they'll be saving hundreds if not thousands of lives much sooner than we will, as we fumble to determine which is the standard that is best for the long-term roadmap in the Western world.
In October, China mandated the use of CV2X and gave it a dedicated band of spectrum. In the US and Europe, the spectrum issue is unresolved, and there's a split on which technology to use. Settling the standard matters. If the federal government mandated a technology today, it's estimated up to 8.1 million car crashes and 44,000 deaths could be prevented. So how are the technologies different? Both are designed to connect cars directly to other vehicles and the infrastructure around them, but the cellular tech can also harness a 5G network's wider coverage, greater bandwidth, and crucially, its lower latency.
That 1 millisecond delay of latency in 5G to let your car know that there's a car coming around the corner that you can't see is going to be critically important. Today with 4G, that might be 10 or 20 or 30 milliseconds. It'll be crucially important to the safety levels.
The Wi-Fi based standard also has low latency, and backers like chipmaker NXP argue that it's a better option because the technology is mature and ready for deployment now. But supporters of the cellular tech say it has superior range and is more secure. Byton is a US EV startup that will build its car in China and bring it to market with basic self-driving capabilities.
5G will enable vehicles to talk to different infrastructure. It'll enable vehicles to talk to each other. Autonomous driving can use up to 1.5 terabytes of data per hour. That data needs to come into the vehicle and leave the vehicle.
CV2X can evolve with each new generation of cellular network, starting with 5G. It would be as simple as switching the modem. Critics of the Wi-Fi standard say the technology is outdated and not appropriate for the cars of tomorrow. So which will prevail? 5G CV2X is now backed by a trade group representing more than 100 car manufacturers and chip makers, including Qualcomm.
Vehicles are becoming more and more autonomous, relying upon cameras and sensors. Once we start blending in both 5G and cameras and sensors, we get to see a far more transformative experience.
A European Commission plan for the Wi-Fi based standard was defeated in July, opening the door for a 5G standard supported by Audi and BMW. In the US, the Trump administration has put off making a decision. But Ford isn't waiting for Washington. In January, the car maker committed to deploying CV2X in its cars from 2022. Currently, General Motors is the only US car maker promoting the older Wi-Fi standard. Bloomberg New Energy Finance says in the long term, the US, Korea and Japan will adopt the cellular option as they aggressively deploy 5G networks. For now, the Western world's left it to automakers to fight it out over which standard to adopt. Ed Ludlow, Bloomberg News, San Francisco.
So, when we use connected cars, we use a lot of information about the driver. So there is a data privacy and security concerns. While connected cars offer tremendous benefits, there are concerns about data privacy and security. Protecting sensitive personal and vehicle data is a critical challenge for manufacturers and regulators. Cybersecurity measures are being developed to safeguard connected car systems from potential threats.
Underpinned by connectivity, the vehicle becomes a real living entity, and the possibilities of what a car might become are endless. Exploration means finding the questions to ask and then look for those answers. I'm driven by how the human behavior intersects with technology and how I, as a service designer, can use that as a design material and create services that create value. Polestar was the first car to have Google Automotive Services inside. The connected vehicle is clearly a trend that is here to stay, and what we need to do is to explore how can we work with this. Exploring with the methodology from design thinking and service design helps us predicting the future. We can't do everything ourselves, and this means that the ecosystem is continuously growing, and this is the future, to design for service ecosystems rather than for a specific car or technology. Working together cross-functionally in the organization, but also sometimes in a grander ecosystem of organizations. The car is only used 5% of the time, which means that it's an unused resource for 95% of the time. Imagine what we could do with all that time. What we have is a car that is connected, and we also have a platform that invites people to develop for the car. The future may well be fully autonomous. It means also that we can expand the usage in terms of moving into a third room, an extension of the office or an extension of the home. What we will give you is a continuous update of the software. One of the benefits with over-the-air updates is that you don't need to go into the workshop to get a software update. From a sustainability perspective, it lasts for longer. We talk a lot about innovation all the time, but in my opinion, innovation is just a product. How to get there is through business design, and it's the only way of achieving that. The opportunities are endless. It's the imagination that limits us. I think it's so interesting with the limitless connectivity because it's something that we now expect. The methodology that we use is to disrupt and to look for new answers, which is super interesting, especially from a service design perspective. I imagine a future where nothing is technically impossible.
So there are government regulations and standards about connected car systems and data. Governments worldwide are introducing regulations and standards aimed at ensuring the safety and security of connected car systems and data. These measures also promote interoperability among different vehicle brands and technology providers, fostering a cohesive and secure connected car ecosystem.
Imagine a future where vehicles talk to one another and to critical infrastructure. This connected vehicle technology can change our transportation system as we know it by enabling safe, interoperable, networked wireless communications among vehicles, infrastructure, and personal communications devices. Connected vehicles provide drivers with 360-degree awareness of similarly equipped vehicles within a range of approximately 300 meters. This secure system keeps personal information private and does not track your vehicle. Drivers will receive warnings that inform them of potential hazards through a visual display, seat vibration, or tone. These are only warnings. The driver remains in control of the vehicle at all times. However, the technology can also support limited automated functions in which the driver only cedes partial control of the vehicle. Warnings can help drivers respond quickly to avoid potential crashes. For example, the Intersection Movement Assist application warns drivers when it is unsafe to enter an intersection. The Do Not Pass application warns drivers when it is not safe to pass a slower moving vehicle. The Emergency Electronic Brake Light application notifies the driver when an out-of-sight vehicle several cars ahead is braking. And imagine the value of this blind spot warning application, which lets this commercial driver virtually see what's happening in his or her blind spot. Connected vehicles can communicate with smart roadside infrastructure like rail-grade crossings to alert drivers when a train is coming, even if the driver cannot see or hear the approaching train.
So, in conclusion, connected cars are reshaping the transportation landscape by enhancing safety, efficiency, and the overall driving experience. While challenges like data security must be addressed, the potential benefits, including reduced congestion and a more eco-friendly transportation system, position connected cars as a pivotal element in the future of transportation. And from now on, Juno Park will present about the next part.
Now I'm going to talk about the future transportations in regard to the mega-urbanization. In the future, cities will continue to develop and continue to attract large populations, and this phenomenon is called mega-urbanization, where the number of cities with a population of over 10 million of people is increasing. It is predicted that about 2/3 of the world's population will live in a major city in 2015. Due to mega-urbanization, cities will be larger and the efficiency of the mobility will decrease. Therefore, a new way to enable long-distance travel and solve traffic congestion is needed. A first possible solution for mega-urbanization is urban air mobility. In the future, we might use small and highly automated aircraft to carry passengers or cargo within cities. To enable the vehicle to be used in low altitude, vertical takeoff and landing technology is needed, such as a drone. Drone taxi was introduced in 2017 in Dubai, which is a large drone that transfers passengers without human drivers. Drone taxi was piloted in 2020 in Korea, and it is expected to be commercialized in 2025. I will skip this part since there is not much time left.
South Korea held a test run for its...
There exist significant challenges in drone taxi yet. First, there are some technological challenges where current battery technology is not sufficient to keep the vehicle afloat for a sufficient period of time. The vehicle has to lift hundreds of kilograms for at least 2 hours, but current technology can't afford this maintenance. Also, there are noise issues. To operate the drone taxi in urban areas, it has to make sufficiently small noise. Also, second, there are safety concerns. When the vehicle crashes, it might occur a great damage because the route of the vehicle is not limited to roads like cars or buses. If the vehicle crashes with a building, it might occur a severe accident. Third, we need a system to control numerous vehicles and handle their takeoff and landing. Also, the regarding infrastructure must be built, which takes an incredibly high cost. Next, what I'm going to introduce is a train. A train is another way to enable the transportation within large cities. The trains are getting faster and faster to enable long-distance travels. There was a TGV test conducted in 2007, and it was revealed that the maximum of current train systems is about 600 km per hour. One of the most fastest train, Shinkansen, is operated at about 300 km per hour. I'll show you the part of the TGV test.
Formidable!
So since the maximum speed of the current train is 6 km per hour, the method to levitate the train started to be discussed. The problem of current train system is that friction occurs as the train moves along the track. So the proposed solution is to levitate the train, and there was a hover train which lifts the train using the lifting force. But this kind of approach was dismissed due to many issues. Second, there is a maglev, in other words, magnetic levitation train, which uses a magnetic force to lift the train.
BizTech Korea's hashtag introduces the latest technical trends that have garnered a lot of attention on social media. Board. The means of transportation that we use every day has implemented magnetic levitation technologies, and it has turned into a transportation system of the future. It is magnetic levitation train, and you might have already heard the word before. BizTech Korea's hashtag introduces the latest technical trends that have garnered a lot of attention on social media. We use every day has implemented magnetic levitation technologies, and it has turned into a transportation system of the future. It is magnetic levitation train, and you might have already heard the word before.
자기부상 열차는 접촉이 없고 분진이 없고 소음이 없는 친환경 교통수단입니다. 현재 인천공항에서 상용화되어 노선에서 운행하고 있습니다. 자기부상 열차는 운행 중 소음과 진동이 적어 승차감에 유리하고 도심 환경 속을 운행할 수 있는데 최적의 교통수단이라고 할 수 있습니다.
Let's have a trial ride on the magnetic levitation train, which has loads of strengths. The train departs after the safety check. It produces much less noise in comparison to general trains, which produce about 100 decibels of noise. How can such a huge train move without generating loud noise?
도시형 자기구상 열차의 운영 방식은 두 가지로 요약될 수 있습니다. 부상과 추진이 그것인데요. 부상은 상전도 흡인식 방식을 사용하고 있습니다. 추진의 경우에는 유도 전류를 이용한 선형 유도 전동기로 추진을 하고 있습니다.
The absence of wheels makes the trains frictionless. And as it floats above the rail, it doesn't cause noise pollution. Also, the train can drive smoothly on sloping roads.
네, 앞으로의 자기구상의 미래라고 얘기한다면 현재 우리나라에서도 시속 1200km급 아음속급의 하이퍼튜브 익스프레스가 현재 연구개발 과정 중에 있습니다. 자기구상 열차의 미래는 말씀드린 바와 같이 초고속의 열차로 우리 생활의 발전과 도움이 될 것이라고 예상하고 있습니다.
There are three major technologies to lift the train. First is an induct track, which uses a permanent magnet to lift the train. However, the magnetic force is not powerful enough to enable maglev. Second is the electromagnetic suspension, which adopts electromagnets. A maglev in Incheon Airport and a maglev in 국립중앙과학관 near KAIST uses this technology to lift the train. Third is electrodynamic suspension. This uses the semiconducting magnets to lift the train. This method can enable faster trains than the EMS system, but needs extremely many power to maintain low temperature for semiconducting magnet. This technology is planned to be used in Chuo Shinkansen, which will be opened after 2037. I'll skip this part. Another issue of lifting the train is that lifting the train occurs air resistance, and the air resistance disturbs the train to accelerate. Thus, a tube train was proposed where the vehicle is covered with a capsule and the train moves through a vacuum tube. Hyperloop is an enhanced version of tube train, which is planned to be developed by Tesla. A goal of Hyperloop is to increase the speed to 700 km per hour and even faster to 3,000 km per hour. It combines multiple levitation methods. First, there is a lifting force, but since there is only a little air in the tube, there is only a little lifting force. Second, it uses induct track to get the magnetic force. And third, it sprays the air at the rear to create an air bearing to lift the train. Acceleration and deceleration is done by using a linear motor on a similar principle to a coil gun, or namely railgun.
Hyperloop is a new form of mass transportation that will set the standard for 21st century travel by connecting cities in minutes. It starts with a near vacuum environment inside a tube, which enables high speeds and low power consumption by nearly eliminating aerodynamic drag. Inside that tube, battery-powered pods glide at speeds up to 670 miles per hour, comfortably, safely, and quietly, using our proprietary magnetic levitation and propulsion. After building and testing the world's first Hyperloop system, we are now focused on our commercial product. The key to our product is guided by a design that is elegant through its simplicity, future-proof due to its modularity, and guided by the principles of this century, not the last. To do this, we've moved levitation, power, and propulsion onto the pod. Our proprietary levitation engines make Hyperloop 10 times more efficient than the world's fastest maglev trains today. The engines contain arrays of electromagnets, which lift and guide the pod within the track. Hyperloop also supports on-demand service and high throughput by having pods travel in convoys. Unlike train cars, pods are not physically connected, which allows for individual pods to have different destinations. Just like a car taking an off-ramp, pods can split off while the rest of the convoy continues on. The absence of moving parts on the track and the advantage of levitation and guidance on top of the pod allows for high-speed switching and convoying to take place seamlessly. These next-generation innovations not only enable ultra-fast speeds, but provide on-demand, direct-to-destination service, carrying tens of thousands of passengers per hour per direction at airplane speeds with zero direct emissions. Fast, effortless journeys that expand possibilities. This is Virgin Hyperloop.
There still are challenges in Hyperloop. First, maintaining the vacuum state in the tube is very challenging. Since the tube can't be perfectly vacuum, there exists a little air inside the tube, and thus a sonic boom can occur. This kind of sonic boom can give stress to the tube, and it will give some damage to the tube. Also, maintaining the vacuum state when passengers get on and off the train is an onerous job. A method to efficiently get people on board is needed. Also, air leak is very dangerous. It will be a great threat to passengers, and it is also hard to rescue passengers when an accident occurs inside a train. Finally, similar to urban air mobility, it needs a large cost to build an infrastructure for Hyperloop. These challenges have to be overcome to make the technology practical. Now this was our presentation, and we will proceed to the discussion.
Yes, thank you. Thank you very much. This was very interesting. Yes, we have roughly 10 minutes left. So maybe we can have a short discussion, and maybe there will be more time for discussion on Friday, depending on your schedule, how you plan to divide the time on the Friday presentation, right? So yes, as usual, let's now take a short break, maybe 3 to 4 minutes. Please keep the discussion slide on, and we'll turn on off video so that everybody can digest and process their thoughts, and then we'll start the discussion. Short break. Thank you. Yes, and here we are back online after this short break and ready to dive into the short discussion. And some interesting starting points are already up here on the slide. So now it's time for the other students, the participants, not those who made today's presentation, other students to join the discussion, to share their thoughts, to ask questions, to give comments. Yeah, somehow this seems to be the hardest part of the entire course. Come on, just speak out. There's nothing to be worried about, right?
For the first question, I think that's.
I mean, can you turn up your volume?
Okay.
Thanks for speaking up.
Yes. What about? Okay. I think that the main thing that they should be considering during emergency should be safety. They should prioritize minimizing the damage caused or the harm caused to both the passengers and the pedestrians, and also primarily having preservation of life in mind.
Thank you. Yes, good point. More comments?
I think I must say that safety is the best decision, and I think that's right too. And I'm just curious that nowadays there are some self-driving cars in course now, and what's their principles and values now?
Yes. So that was a question. or maybe a rhetorical question? Yes?
For the second question, who is responsible when a driving car accident occurs? I think it depends on the situation of how the accident occurred. For example, in vehicles with partial automation, where the driver is expected to remain engaged with the driving task and maintain control of the vehicle, the driver could be held responsible if the accident occurs due to their negligence. And if the accident was due to a flaw in the vehicle's design, manufacturing defects, or inadequate safety features, the manufacturer might be held liable. And if the accident was caused by a software malfunction or a fault in the algorithm that governs the car's decision making, the developer of the software might be held liable.
Yes, thank you.
For the second question, I feel like this is a really important question. Who is responsible? Because this technologies could be used for bad purposes, like terrorist attacks or for criminals to flee the crime scene. So this is a very important question.
Yes. I have a question. I'm wondering, so the biggest impact on our climate comes from planes, because they fly so high that their emissions stay there above the weather, right? So anything that happens below the clouds will eventually be cleared away by rain, but planes fly above the clouds and their emissions stay there for years or even decades. So reducing plane travel, as you suggested, is indeed an important step. But what will be the replacement, right? I guess people will still want to travel to other continents, experience other cultures. And that's also very important culturally, right? The exchange, having foreigners come to your country or visit other countries is very important. So we need some replacement, and maybe there will be some virtual kind of tourism to replace plane travel and without the gas emissions. What do you think? You're muted.
Oh, then you means the replacement of the virtual travel, right?
Right.
Actually, it is our discussion question on the next presentation. So
okay,
we'll think more about that, and we will answer the question the next presentation. Sorry.
Sure. Yes. Damir has asked a question in the chat. Damir, can you ask the question here? Damir cannot use the microphone today. Okay. Yeah. Anyway, yeah, time is up. And you leave us very looking forward to the second part of your presentation on Friday. So that concludes today's session. And now I'm going to turn off the recording.